Hello to viewers, welcome to my channel Science to Technology. In today's show, Rocket Monday, we're going to talk about train to Mars. So let's dive deep into it. Now, first thing you have to understand, Mars is kind of far. Now we have two celestial bodies that all of us are familiar with. First is Sun. So how far is this puppy? Well, it's 8.3 minutes, aka almost 500 seconds, meaning if you're traveling at light speed, it will take you 500 seconds. And then we have Moon, which is very close, which is 1.3 seconds. And you're like, okay, how do we know it is exactly that far? Well, during Apollo mission, they put a retroreflector, and over all those missions, they had put a retroreflector in multiple places. So you can fire laser, and you can fire the laser anywhere on the lunar surface. It will come back with a natural signature, so to say. Fire it exactly where they put retroreflector, it will come with a very clean signal, aka artificial, aka exact distance. So we call laser range finding. That's how we know how exactly far apart Moon is. Like that's how we figured out that Moon is drifting us with in relationship to us by 1 inch per year. Well, like that's precise. And not only they have one retroreflector, they have multiple. Mars is kind of flexible, so to say. So at its closest, when it's almost making love to us, that is 3 minutes. And its furthest, when it's divorced from us, that is 22 minutes. That's 1,320 seconds. That's far. So how the heck that's possible? Well, simply you have to understand our orbital rotation is not synced. So Earth can take over, basically Earth, Sun, Mars can happen in such a way where you have Mars on one side, Sun on the center, and Earth on the other side. That's what we call conjunction. And then you have basically all three things, basically Sun, Earth, Mars, in that exact order that we call opposition. So basically, if you have Sun in between, we call it conjunction. If Sun is not in between, we call it opposition. So opposition is the best. Now, like, wait a minute, why Sun in between is called conjunction? Well, Sun is the center, that's why. Is Earth in between from Mars point of view? Yes, so that's why we call it opposition. Earth is in opposition to Mars, to Sun. Don't ask me, I did not design it, but this is what it is. So at closest point, it's in opposition. So you can go as low as 3 minutes, and as furthest, you literally have to go through basically Sun. At that point in time, it's 22 light minutes far apart. So that's far. Now, let's put some number on these things. When you are talking about low Earth orbit, basically the first thing we do, you are talking about 7.8 kilometer per second, bare minimum. Generally, let's just say 8 kilometer per second, because again, you do have to have a bit more extra oomph, so contract the drag and gravitational losses. So you need that much. Now that is big task, but you still need more oomph in order to go into deep space. Basically, if you want to be free of Earth's gravitational influence, you need some extra oomph. You need upwards of 11.2 kilometer per second. So that's fast, so to say. And we do Hohmann transfer method, which allows us to just add 3.2 kilometer per second on top of LEO speed, and then you can just go to Mars. But you have to understand, when you are talking about sending, not mission, like sending a civilization, so to say, basically where you're like, no, we're not dumping 1 kilogram, 1 ton or 2 tons like rovers. We are dumping hundreds of ton. You do need a way to basically dock with Mars. Right now our system is yeet directly into the Mars. Basically, we try to align our corridor, but it's a direct dump approach. Basically, you go and you just slam into the atmosphere, hope your heat shield handles it properly, and then hope for the best. So generally, if you are talking about some big things, that's not recommended. So you do need a way to orbit Mars. That will also require you to fire engines and slow down. And if you directly went with Starship approach, lol, because you can't do that. It does not have enough propellant. So Mars, that's how you're talking about Mars. Now, unfortunately, too many people are smoking Elon weed, which is unwise. And let this very clear. If you are old enough, you must have remembered this. Elon Musk always wanted to go to Mars. This is before Tesla became a thing. This is just after PayPal became a successful thing. In that point of time, he wanted to send a greenhouse to Mars in order to show that you can have something growing on Mars. Again, good idea, but he went to NASA, and NASA was like, lol. And then he went to Roscosmos. They're like, lol. So he got really pissed off. He's like, okay, let me lol both of you. And that's how SpaceX was built. And after that, he kept working on it, and this puppy came to be, basically Dragon capsule. Now, Dragon capsule is basically funded by NASA, simply because NASA wanted what we call commercial crew mission. And before they jumped into commercial crew, they needed to have commercial resupply missions. So that's how they were getting all the funding. And once he actually has something where it's like actual funding, it's actually, in this sort of testings were happening, they were like, okay, what if we just boosted this puppy up? So take this. This is the early phase. In that time, they were expecting propulsively landing. And be mindful, the concept was stretched to such a point where it's like, what if we use this puppy directly to land on Mars? Let that be very clear. Dragon capsule stretched a little bit, Red Dragon as they called it, directly landing on Mars. And they basically NASA was like, yeah, we are not paying for that, but we will give you technical support. The reason for that is NASA was very interested into propulsively landing, because if you have paid attention to NASA's recent rovers, they are utilizing what we call sky crane, meaning they have a rocket that is a crane. So this idea was really desirable for them, and for this sort of new things, more data, more better. So they were okay, we're gonna give you technical support, meaning our engineers will work with you, because in this design the biggest hurdle was how the heck you have legs coming out of the heat shield without compromising the heat shield. Like again, space shuttle also had that issue. How the heck you have those doors closed and you do not have any hot gas going inside them? That was a very complex engineering, so to say. So this happened in basically April 2016, and at that point in time they only had Falcon 9, which again, that did not had enough oomph to yeet something at almost 12 kilometers per second. So they that time they announced this puppy, which is Falcon Heavy. So this all happened, and their targeting was, back in those days, landing on Mars by 2018. Of course, uncrewed, but 2018. Now, if you know your calendars, you know for a fact that this video is made in 2025. That did not happen. And in July 2017, they yeeted all of that concept and they basically jumped into Big Falcon rocket. Now, Big Falcon rocket was too goddamn big. It was stupendously big. It was like you are literally building a Starship from Enterprise. It was like that stupid. It's like Starship Enterprise directly. It was just bonkersly stupid. So why was that? Why it was so huge, like 300 to 500 tons? Yeah, that's how he was talking about back in the days. So the primary problem was he wants one Starship to do everything. Basically, same way he was smoking that we're gonna put human inside this. Again, not on first mission, but second or third. And this human is gonna be here and stuck here for years. I'm like, what the hell? And again, that's why if you pay attention to another project that happened, Mars One, they were relying on this, because again, SpaceX actually told them, it's like, yeah, this can be done. I'm like, you're gonna put person in a oversized coffin? That's not recommended. For 2 years, really not recommended. So what do I mean when there's one thing to do it all? Well, he wants something that can take off from sea level. Basically, you have put it on booster, yeet from sea level, go to low Earth orbit, then go to deep space, then go to Martian orbit, then go and land. And again, you can remove the orbiting part, but you have to do LEO orbiting, and because again, otherwise you can't refuel it. Martian orbiting can be bypassed, but you land. And be mindful, that's one-way ticket. You cannot come off unless you have a giant civilization on Mars waiting to refuel you. You can't come back. So that's why. Let Elon Weed go. Before you're like, oh, he's saying he's doing it. It's like, yeah, I'm old. I've been there. I was there. Like, I actually remember this. Cannot tell you how many people were like smoking it at that point in time. I was like, yeah, Elon Musk plan on landing on Mars by 2020 is not crazy. I'm like, 2025. He has not even done moon. Because again, the fundamental philosophy is flawed here. He wants one thing to do it all. That's why that BFR was so stupid. It was like, he wants one thing to do everything. We do not have, E equal to MC square engine. We don't have Epstein drive like we have in Expanse. So how would you actually do it? Like, let's say you give money to China, you give money to NASA. How would they do it? Well, they are building what we classify as interplanetary transport craft. So the idea is very simple. You have one craft, it does one thing. LEO to space, and only for that. Meaning you dump your cargo modules, you dump your basically habitats, space habitats, not habitats for Mars. Space habitat, those will be classified as cargo. Mars habitat would be cargo. But you're talking about space habitat, specifically a space station, traveling space station, that will be, and it's supposed to only handle two things, basically low Earth orbit and travel to lower Martian orbit. Basically, you don't have low Mars orbit, you have lower Mars orbit for that. And docking from Earthship, meaning because again, it's not taking off from the ground as a complete thing. You're gonna assemble it, then how the heck you're gonna dump a basically crew into it? You're gonna dock, and benefit of that, you have a lot of options. How do you do that? And then you're gonna build two crafts for it. You're gonna have the one main craft for landing, actually touching Mars. You will have two craft, these two puppies. So you're gonna have what we call crew lander. Now crew lander is basically shuttlecraft. The core point is it lands and takes off without refueling. It's basically designed on the same philosophy as a lunar lander for Apollo mission. Basically, you land, if everything is fine, you enjoy your mission. If something goes bad, you yeet out of there. You are not like, okay, I thought there would be a civilization here refueling our thing. No, no. You land, you do your thing. If everything is fine, awesome, you come back. If something goes kaput, you can kaput out of there. That's there. Another craft would be designed that is cargo variant, and this variant is basically stripped down version of crew lander, because again, all they have to make sure of is like this puppy can go through atmosphere and just safely decelerate, nothing more than that. Basically save all the weight penalty of ejection system, save all that, put that just as a habitat payload. So you're gonna carry two of that, basically two classification. Classification number one, crew lander. Classification number two, service habitat cargo. Basically cargo and crew. You're gonna have two separate craft, because cargo craft will not have yeet capacity. And how many of you are? Generally, you will have multiple of two. So you're gonna have 4 total, or 6. Some designs had 8 also. But again, people are like, yeah, 4 is a good point. Anything more than that is like overkill, because again, you can add as many as you want. But problem is this. Thrust requirement of this puppy becomes exponentially harder, because it has to go from low Earth orbit to deep space. That does require extra oomph, almost 4 km per second of oomph required. So you're gonna have that. And this puppy, the main interplanetary transport, this will have rocket engines, because again, ion engines does not have enough oomph to go from low Earth orbit to interplanetary quick enough. You can do it. You can do elliptical orbit raising. It can be done. It's just that too slow. It can be done if you want to just dump cargo into Mars. That can be done. But for human system, that's not acceptable. So they will have a normal proper. And again, that's why huge fuel tanks. So this is the craft, and you're gonna have huge fuel tanks, so to say, and they're gonna yeet from low Earth orbit to deep space, and it's only gonna give a little bit of surplus, which will not be enough to go to Mars. But then you're gonna trigger on what we call solar ion engines, and because you have giant solar systems, you have the ability to freeze the propellants. You will not have to worry about boil off, and it can slowly keep pushing you. Meaning, in that, technically you will be in zero gravity, but you will have actual gravity. Basically, if you keep things, it will fall back through the thrust direction. So again, mild thrust. So if you put a pen there, it will slowly, very slowly, but it will, because you are accelerating, and then you will flip it backwards, decel, exactly how we do in Expanse. But again, this time it will be very slow, very slow. All you are doing is reducing the load on the engines when it has to decel for Martian capture. And no magic tech required. Again, this is the exact design philosophy after Apollo era was worked on, whereas like Apollo was done, okay, how do we go to Mars? This is exactly what they came up with. Exact same thing China came up with. Exact same thing every space agency comes up with if they are not smoking Elon weed. They're like, okay, how do we do this? This is what we can do right now. Assemble a craft in low Earth orbit, which again, we have done that. Multiple. Soviet Union have done that. Technically, Russia has done that. USA has done that. China has done it. So 4 people have figured out how to dock things in space. We can do that. And benefit, each things are tailor-made to do one thing only. Meaning a spacecraft that is designed for space. A landing craft designed for landing. Basically dump material on Martian surface. Designed for that. That's the whole point of interplanetary transport. So if you look into NASA's archive, which is openly available for public, that's what you will find everywhere. No magic technology required. No engine that is so working so goddamn hard, it's like apachu. So you don't have to worry about that. All the technologies are current. Now, what is the benefit of this sort of approach that every government and country is doing that? Well, simple. You are not asking one thing to do everything. You are just doing sea level to LEO docking, which again, we have multiple options. Right now, planet Earth has options from Russia, options from China, options from America. America itself has at least 2 to 3 options working. Again, one is fully working, others are like, we are almost there. So we have options. How do you load crew into this craft safely? All things are done, all things are sorted, no problem. And then traveling space station, the cargo system is a traveling space station. Why is that a big deal? Well, because if you are free in terms of how do you arrange the things, basically only limited by the cargo space, but you do not have to worry about, oh, where are we going to put heat shield, how we're going to have canards, how we're going to have header tanks. If you're not limited by those things, you can really focus on making it safe for long duration. ISS is safe simply because it's below Earth's magnetic dome, so to say. Magnetosphere, we are below it. So if you have to go above that magnetosphere, like Apollo system, you want to land on the celestial body as quickly as possible, because once you are before this, like you jumped from the outside of the magnetic dome, magnetic shield, and then you are here. Moon is here. You are here. Here's the deal. You are getting radiation exposure from 360 degree, all sides, every side. You are getting cooked. But with the moment you land, 50% of it disappears. So that's why people want to land as quickly as possible. You do not want to be in space for long duration. Again, it can be done for short duration, but you do not want to do it. So how the heck you make sure if this puppy is safe for you? Because it's a thing only designed to do one thing. Generally have large water tanks also on the outside. Why? Water is really good at stopping radiation. Heck, you can see the small version of it is in ISS. So whenever sun starts to sneeze too much, solar flare activity goes up to solar maximum. They have a place where they just go in and they have water tanks around it. That's the easiest way. And again, other designs have also included that we can recycle water. Water is cool, easy, super awesome. But what the hell to do with poop? What you put outside of the craft, that also adds a, well, mass, just mass, and it has enough hydrogen content that does slow down radiation. So radiation shielding, you do not have to fight radiation shielding with heat shielding. You're like, okay, this is just radiation shielding. This is what one thing it does, and one thing it does well. And you have multi-mission structure, meaning this thing not only like go, come back. No, you can keep doing this. It can keep cycling as many times as it requires, simply because there is no landing stress. All the acceleration and deceleration are very smooth, very gentle. And again, most of the oomph will come from iron engines. You just need that initial push from chemical engines. As long as you can refuel it, which again will be less compared to refueling the whole goddamn Starship, you can do that. And lander topology, this exact topology, decent ascent vehicle, Dave. This puppy is exact same topology as we have for Moon, and we know it does not require refueling. Be mindful, this is much easier to do on Mars compared to Earth, simply because Earth has really deep gravitational well. Mars is like, and atmosphere lightweight, it does make your ascent a bit easier. And cargo dump is just like, yeet. So that's what NASA was designing in 1990s, where like, okay, just yeet things on the Mars. We do not need to get them back. We do not, like, there is no point. I have no idea how the heck Elon Musk is like, we want that Starship back, but we do not want the people back. I'm like, what cocaine are you on? Like, that's not normal cocaine. That's Elon cocaine. It's like NASA was like, yeah, bro, people are the expensive part. This crew, nothing. Don't worry about it. Just drop it there. So that's what we have to do. And crew does not need anything from Mars, meaning this can only happen if you have a whole civilization there already. Like now they are thinking, okay, what if we have robots there? I'm like, yeah, cosmic radiation and bit flips do not happen. So again, it can work. It's just that by the time you solve it, you'll be like, what was the point again? So this is the benefit. That's why every civilization, aka governments and people who are actually not smoking, they're like, yeah, this is how we're going to do it. We're going to build one craft, does one thing quite well. We're going to have one lander which has emergency yeet capability very well. We're going to have a dump craft. We just dump a tonnage into that. And that you can keep doing again and again and again. And again, the poop shield will start to grow. So you can keep doing that. That's the reason why people are excited about interplanetary transport, not Starship. And again, why the reasons original Starship was so huge, they wanted to do all of that in one craft. And again, outcome was, it was too stupid. It's like, yeah, what if we had like 500 ton to low Earth orbit? I'm like, bro, you are exploding right now. So that was the problem. That's why that design is so bonkers. They wanted to fit everything into one. So what can we expect in the future? Well, here's the deal. Current Starship, if you really force it into Mars craft, is just one-way ticket. Elon Musk is saying that and people are still talking about it. That does make me lose faith in humanity, but it is what it is. And you need whole industry to refuel it. I have no idea how the heck everybody's like, oh yeah, we're just gonna go there, we're just gonna drill and we're gonna have water and we're gonna have solar energy, as if like Mars does not have a dust storm that can block out the sun for almost half a year. And then it's just like, I know everything is just there and it just works. Given the fact that all NASA managed to do is have a MOXIE that produces some grams of oxygen, which can't even keep a human alive. And you're gonna refuel a Starship. So what's the problem in that philosophy? Philosophical problem is same. Nothing is suited for everything. You cannot design it. For example, this is my screwdriver kit. Why do you have so many bits? Because you cannot design a bit that works with everything. Law of physics does not allow that. Same thing is happening here. It's like, what if one Starship can do everything? It's like, what if you don't smoke? That's the whole point. Without interplanetary transport, it's just a dreaming about Mars. Can you do it? Of course, you can do it. You can force it. And there might be enough people who have nothing left on Earth where like, yeah, just send me on one-way slow ticket. And again, you will be cooked by radiation. Very slowly. Radiation is one of those things. It does not matter on year 1. It matters a lot on year 5. So it's one of those things. And be mindful. Claiming is free. Elon Musk was doing this, I don't even know how long ago. It's like, yeah, we have everything. It's like almost all of his designs is like, we already have things on Mars. It's like, now it's just like, okay, we have robots on Mars. I'm like, bro, you were having self-driving car long ago. You still don't have it. And no, it's not self-driving if you have to look at the road. There is a reason. There is a legal reason why Germany flat out banned them allowing saying that. And again, in USA, he bought judges or judges were smoking. It's like, no, it's okay if you have like this and all that. No, that's not self-driving. Autopilot system does not just like randomly go, hey, you are not looking. So claiming is free. Elon Musk is free. So you have to just let things go. And this is really bad for 9th time in a row that you have failed to reach orbit. Again, if that happened, you dumped your payload into orbit and then re-entry bad happens, no problem. It's like, hey, nobody has tried that. Try dumping payload into orbit. Nobody has done that. That would have been awesome. But 9 times, it's like, yeesh. 3 times, exact same boom event is like, yeesh. So that's why I'm saying like that they're very clear. You can smoke as much as you want, but be reasonable about it. So this was my presentation on why do you need a train to Mars and why it has to be non-Starship. Hopefully you have liked it, learned from it. In that case, please hit the like button, share it amongst your friends. That will help me a lot. If you didn't like it, didn't enjoy it, urge you to press dislike. Press it twice to show me disappointment. Please leave a comment because I do try to reply to all of them. Subscribe, press the bell icon if you're free. And as always, thanks for watching.